Hello everyone, this is Himanshu Rathore from Department of Mechanical Engineering of Arya College of Engineering IT. Today we are going to discuss our topic preliminary design and detailed design of subject product development and launching. In our lecture second, we are going to cover the topics are subsystem usage, subsystem specification and compatibility. Subsystem usage. Subsystem can be used in a number of complementary ways to partition the system into units which can be independently ordered, configured or delivered can be independently developed as long as the interfaces remain unchanged, can be independently deployed across a distributed computational nodes, can be independently changed without breaking other parts of the system. Subsystems are ideal for modeling components, the replaceable units of assembly in component based development that are larger than a single design class. Identifying subsystem. A complex analysis class is mapped to design a subsystem. If it appears to embody behavior that can't be the responsibility of a single design class acting alone, a complex design class may also become a subsystem. If it is likely to be implemented as a set of collaborating classes. Subsystems are also a good means of identifying parts of the system that are to be developed independently by the separate team. If the collaborating design elements can be completely contained within a package along with their collaboration, a subsystem can provide a stronger form of encapsulation than that provided by a simple package. The contents and collaboration with the subsystem are completely isolated behind one or more interfaces, so that the client of the subsystem is only dependent upon the interface. The designer of the subsystem is then completely isolated from external dependency. The designer is required to specify how the interface is realized, but they are completely free to change the internal subsystem design without affecting external dependencies in large system with largely independent teams. This degree of decoupling combined with the architectural enforcement provided by the formal interfaces is a strong argument for the choice of system over simple packages. This is the way of identifying the subsystems. Now, modeling subsystems. Subsystem may model as either UML subsystems or UML components. These constructs provide almost equivalent modeling capabilities, including can group classes to define a large granularity component, can separate the visual interface from internal implementation, can have instances that execute at runtime. Some difference between modeling options are subsystems explicitly include the notion of specification and realizations. This can be expressed with components, creating separate specification and realization model of components. Subsystems are also packages. Components, on the other hand, can be composed across packages. If you wish to maintain a packaging hierarchy orthogonal from your component, composition component could be better choice. Subsystem that represent existing product. Where an existing product is one that exports interfaces, that is operations and perhaps receptions, but otherwise keeps all details of implementation hidden, then it may be modeled as a subsystem in the logical view. Example of products the system uses that you may be able to represent by a subsystem includes communication software, means middleware, database access support, RDB, DMS mapping support, application specific product. Some existing products such as collection of types and data structures may be better represented as packages because they reveal more than behavior and the particular content of the package that are important and useful, and not the package itself, which is simply a container. Common utilities such as math libraries could be represented as subsystem if they simply export interface, but whether this is necessary or makes sense depend on the designer's judgment about the nature of the thing modeled. Subsystems are object-oriented constructs that are classifier as well as packages. A subsystem can have instances if the design so indicates. Subsystem dependency restrictions. Subsystems differ from packages in their semantics. A subsystem is a kind of package which provides behavior through behavior. One or more interfaces which utilize packages provide no behavior. They are simply containers of things which provide behavior. The reason for using a subsystem instead of package is that subsystems encapsulate their contents providing behavior only through their interface. The benefit of is that unlike package, the content and internal behavior of a subsystem can change with complete freedom so long as the subsystem interfaces remain constant. Subsystems also provide a replaceable design element. Also, two subsystems that utilize the same interface are interchangeable. A subsystem should minimize exposing of its contents. This is diagram of subsystem dependency. Subsystem A, subsystem B, target, or we can say package C. Subsystem specification. Both firm and probable decision are identified and specification are produced for each subsystem. Based on this design decision, interfaces to each subsystem are specified completely so that other subsystem designers can continue to the detailed design phase. Subsystem specifications are integrated into complete product design. This phase represents the last exploratory phase of the design process. The content of subsystem are divided into subtypes: specific element and relation elements. The specific element together with the operation and reception of the subsystem are used for giving an abstract specification of the behavior offered by the realization of elements. The collection of realization element model the interior of the behavior unit of the physical system. The separation of specification and realization essentially allows for two separate descriptions of subsystem. The specification serves as contract that defines everything that a client needs to know to use the subsystem. One option for modeling specification and realization, if not directly supported by the modeling environment, is to place two packages, specification and realization, inside each systems. One motivation for specification is to support multiple realizations. This is not directly supported into UML. If you wish to support multiple realization, create separate realization subsystem and draw realization from each realization subsystem to the specification subsystem. Subsystem, when and how to use. If the internal state and behavior of the subsystem is very simple, it is difficult to specify the subsystem by its exposed interface state diagram to describe the behavior and discrete text. For more complex internal state and behavior analysis, classes can be used to specify the subsystem at a higher level of abstraction. The subsystem realization state or behavior is complex and the specific need to be expressed as simple as possible in order for client to use it effectively. Second, the subsystem is a usable assembly component intended for assembly into a number. Third, the subsystem internals are expected to be developed by separate organizations. Fourth, multiple implementation of the subsystem need to be created. Fifth, the subsystem is expected to be replaced with another version that has significant internal changes without changes to the externally visible behavior. Subsystem dependencies. A specification should define a dependency. There are the interface and visible elements from other subsystem and packages that must be available in all compliant realization of the subsystem. A realization may have additional dependency introduced by the designer or implementer. Relationship to implementation. A fully detailed specification defines everything a client needs to use the subsystem. Means refining the exposed interface and any publicly visible elements so that they are one-to-one with code. Analysis classes introduce a specify the subsystem behavior should remain as high level abstractions. They are intended to be independent of any subsystem realization. The realization element of system should align closely to the code. Thank you. That's all for lecture 2.